Okay, I want to talk about a couple more things in Numpy that are going to help us to make some little tunes here. And you'll do an exercise where you make happy birthday tune, part of it at least. Okay, so one thing I didn't mention is you can actually assign values to NumPy slices. So, I could say, actually going to np.0 sample rate, so that'll make a second of audio, but it's 0, not very exciting. And before I showed you can assign particular elements. That's not going to do much. That's just one sample. So if I want to assign a whole bunch of samples at once, I can do that in a single line of code by saying something like this. Let's say that I wanted to make the first half of this be a concert A. So I'll make just half of the sample rate samples. And so then I'll say x from 0 to sample rate over 2 equals cosine 2 pi. And then the frequency will be concert A, so get note freq 0 times t. All right, so let's listen to that. So let me make this y, not x. So hear how it gets silent in the second half. Okay, and then I can also make the second half maybe not be silent. I'll say, okay, starting at that index halfway through, let me go make a third, something called a third. Okay, so that's a C sharp in this case. And let me maybe say, okay, let me go 3 half seconds of audio, so 1.5 seconds. So I'll do A, C sharp, and then I will do E, which is the 5th, which happens to be 7 half steps above A. Okay, so that's called a major triad. So those are 3 notes that go very nicely together. One thing I can do is transpose this. So I'll say offset equals 1. So what I can do is I can add a constant to every half step here. So that's also a major triad, but it starts at B flat or A sharp, however you want to say it. Let's do it again. So that one starts at a B. Let me go back down to an A just to show you. And then back to a B. Do, do, do. And now we're going to do do, do, do. Okay, and I can also, maybe I'll start at the C sharp. Okay, so anyway, what's interesting about this formula that I gave you is that this is why it's called equal tempered. If I add a constant to every note number, then I just shift this along, but the relative intervals are the same. So this is still what's called a major triad. Okay, so, but also I was just showing you, how to do this by assigning 2 slices. So that's kind of interesting. Just one more quick thing to show you, then I'll have you do happy birthday. I can also add a little bit of noise to this. So I can say y is equal to y plus maybe just a little bit times np.random.random y.size. So it turns out in a NumPy array, the variable .size, that's how many elements. That's like length of a regular array. So let's just listen to this. So you can hear the static in the background, right? If I increase the amplitude of the static, it'll get worse. So now I have this, again, this is the amplitude, but of the noise relative to the rest. Maybe make it very low amplitude now. You can still hear it, but it's not quite as strong. Okay. So now I want you to just to make sure you understood this, I'm going to have you do happy birthday real quick.